Monitoring Devices with M2M Cellular Networks webinar. That's a mouthful. My name is Dana Verstegen. I'm your host for today's session. During the next hour, you're going to hear from Barry Ceci, the CEO of Telog, which is a provider of remote data acquisition for water energy utilities in North America, Aeris founder and CTO Z. Hossein, and Willie Chan, a marketing manager at Symmetry Electronics. And Symmetry is a distributor of wireless, video, and embedded semiconductor products. We're going to do a Q&A at the end of the presentations today. If you have any questions, you can enter them at any time into the questions box in the lower right corner of your screen. Together, this group has decades of experience in M2M, so if you have any questions related to monitoring or the M2M and IoT industries just in general, I have no doubt that they're going to be able to answer them for you. After this session, you will get a copy of the slides as well as the recording of this webinar that will come to you via email tomorrow or the next day at the latest. So we're going to kick off our session today with Z. Hossein. I'm going to send it over to him. Z?
Thank you, Dana. Folks, we will have three people participating in this webinar. I'm going to kick it off with information about Aeris, what we are and what we do specifically from machine to machine, particularly in the pressure and flow monitoring environment. Barry Ceci will follow from Telog Instruments. He's the CEO of Telog Instruments. He will follow me. And Willie Chan will bring up the third part of the webinar, including some interesting information that I hope you all will stay tuned for all the way through to the end. So let me get started. And I'm going to first present some information about Aeris and give you sort of a high-level overview of what we do and how we go about doing it. Our company has been providing machine-to-machine and IoT services for a number of years now. We're headquartered in Silicon Valley, California. And what we do is we provide a complete platform. It's an optimized platform from machine to machine, all the way from connectivity, the data transport on cellular, to application enablement. In other words, looking not just at the transport of the data, but also the content of the data. And recently, we've deployed a new capability that we call NEO for rapid M2M debugging, startups, and deployment to be able to kick off your application deployments much quicker than traditionally was done in the past. Our customers are typically enterprises who are deploying machine-to-machine and IoT applications where they need connectivity, including the ability to ultimately get the analytics from the content for business actions that they might need from that data. The numbers, we're a highly reliable infrastructure designed for machine to machine. We're currently operating in over 190 countries. We're the third largest cellular device provider from a machine to machine perspective in the US, 9th globally. That's an estimate on the global numbers. We're not entirely sure who the other people are and what their numbers are. And we're currently providing a solution that is supporting well over 250 million messages per day. The markets that we serve include healthcare, telematics, consumer auto, monitoring and control, which is the category that this webinar falls under, point of sale, and utilities. This platform, in the center box, you'll see the platform from the bottom upwards. You see us providing the data and voice connectivity services for these devices with full device and session control, tools to enable you to manage your devices properly, through the provisioning, activation, real-time information about the devices, alerts and alarms from the data that is being processed, or whether it's a device that is perhaps transmitting too much. I'll give you more information about that in a little bit, including account-level NOC support, meaning when you contact us, you get through to an engineer or technician who's very familiar with the fact that we're deploying M2M applications and not traditional cellular handsets. And at the very top, you see the connectivity enablement and application enablement, which is to allow the customers we have to use the content of the data, not just the transport of the data. And obviously, on the far right, what you see is the fact that we do cellular as a transport for our services, ranging from 2G, 3G, CDMA, and GSM on over more than 500 carriers, and deploying a 4G LTE solution in the very near future. Now, our technology is built on top of what we call the Aeris M2M platform. At the bottom, you see the AirConnect connectivity services. This is the capability and services that we provide to our customers. This feeds into the M2M core network that's called AirCore. AirCore is a platform that we have built and optimized for machine-to-machine applications, and as you will see shortly, we'll talk about the innards of that system and what we have done to make M2M applications work more efficiently and effectively. That leads into our management platform, the device management platform that's called Airport, that allows you to troubleshoot and manage the devices, to troubleshoot and control the costs across the transports. And finally, our AirCloud application enablement platform, which, by the way, is technology agnostic. And I'll spend a little bit of time describing that, very briefly describing what it's capable of doing. And then you have the applications on top, which are in those 6 markets that we talked about. The support for all of these platforms, all of these systems and platforms, is the back-end system for providing billing and back office support, so that we can provide very flexible billing models, billing solutions for the models that the customers might have. I'll touch a little bit more about that as well in the next few slides. So how have we optimized the M2M structure? We have developed and deployed some custom infrastructure elements, and I'll talk about that briefly over here. First of all, we have some radios that have been optimized for machine-to-machine. Cellular handsets that are designed for human usage are not necessarily optimized for machine devices, including whether it's network or radio capabilities, simply because the mechanisms assume a human user who will be able to compensate for any anomalies that might occur in the network. Machines cannot compensate them, so you have to do something unique and different for them. The systems that we have in our core network include, now these terms are all cellular terms, but rest assured that what you're looking at over here is the key infrastructure elements that are required for any cellular service, and we have our own systems that we have designed, indeed, and deployed, where we can provide some very granular setting of services and some unique custom applications for devices and applications and customers who might have some special requirements. And we can set custom policies for improving service control of machines out there. And finally, the third bullet over there talks about the flexible billing and the ability to get real-time and reporting alerts, because machine-to-machine devices need to optimize the usage of the plans to be able to match the customer's business model as opposed to the kind of handset solutions that consumers usually tend to do. These include things like cross-plan pooling, where you can take the bytes that you might have in an application that transmits less than another device, so it's on a different rate plan, automated activation, automatic suspension, and allows you to control all aspects of the device presence from a billing perspective on the network. The cross-plan pooling, just to complete that thought, is intended to allow you to maximize the utilization of the available bytes that have been signed up for that application. The key capabilities of the system is the full stack, allows you to take telemetry and sensor applications where you can get connectivity and data and the control of the equipment that's in the field, complete secured access to devices that are operating on the network. These applications can be sending their data into our AirCloud system, which is transport independent. So this is where you can get connectivity independent storage as well as analytics, content analytics to make the kinds of decisions, business actions and decisions based on the alerts and notifications that are received from those devices and applications in the field. And finally, you have a complete portal access to the device itself, the management of that device, managing the provisioning, the activation, its billing status, and be able to debug devices out in the network, set some thresholds for your alarms, and basic monitoring of the functionality and whether the device is operating properly in the network or not. Now, where we distinguish ourselves from traditional data transport services that are provided from the carriers is in those 7 circles that you see over there. I'm not going to dive into detail on all of these. That would be a presentation in itself. I'll pick one and give you some more information about that. But basically, from the perspective of what we do differently from the carriers is we take the cellular transports that are offered and add capabilities, enhancements for service and performance, for example. Custom network services for applications that might need the ability for a unique solution that would not be provided in a traditional cellular environment, all the way to enhanced security for the devices as well as customized billing. Let me talk about customized billing as an example of one of those capabilities. The first bullet over here talks about how we distinguish the concept of provisioning from activation. In other words, a device can be live without recurring monthly charges because you're going to need to want to make sure the device has been tested properly. You can do provisioning at the factory if you're doing high volume production that is easier and quicker and better. You can do on-air testing during the factory production. and you're not going to trigger a billing event. You're not going to start the monthly recurring charges for those devices till you're ready, till the device passes certain thresholds in an automatic manner, or you activate the device and go from a provision state to what's called a bill status or an activated state. Those are all the controls that we, in fact, pioneered many, many years ago, and I'm glad to see other people are copying us in that regard. This is something that machine-to-machine devices in high-volume production in particular need to have. We provide very detailed and summary billing, as well as summary billing reports, because you need to have the device usage available to you in electronic formats. You can analyze exactly what happened with the particular device. Indeed, some of our customers are now marketing those devices as well as the data to their own customers, and therefore having detailed usage in summary form or in groups that they can provide, that they can set themselves to decide which devices belong to an independent customer, or for whatever purpose you might want to create a report group, you can get that summary solution. Then, of course, the ability to match rate plans to the specific needs. This is very important. Unlike a traditional cellular service where you only have a few rate plans available to you, we have to optimize, because you may have applications within the same customer who are sending a few megabytes per month, or maybe an application that's sending hundreds of megabytes a month, and you want to be able to match a specific rate plan to that transmission, as well as the ability to pull that data across the devices or even across rate plans. That's essential. So we literally have thousands of rate plans, and many customers, on average, might even have 5 or 6 or 7 rate plans available to them that they can pick and choose from and do pulling across them. So for monitoring and control applications, what are the specific needs that those applications might have? Well, first and most, I'm picking 3 bullet points here. Obviously, there are a lot more, but something to be aware of. First is that these devices are generally battery powered, depending on the location. Not all of them, but they may have limited power availability, so those installations will need to have battery power issues that they would need to manage properly. So, for example, you want to make sure that the power on time, the data is tuned to make sure that the power on time is limited, and they have to make sure that the devices have the appropriate threshold set inside the portal, so that if they go over or exceed the amount of data that is being transmitted, you want to be able to control that either manually or even in an automated way. The cellular technology selection for these devices that are going to be out in the field is pretty important. As many of you all know from some of my other webinars or from industry information, there is a sunset occurring in the 2G GSM space. AT&T has announced that they will be shutting down their 2G GSM services for good reason in about 20 more months at the end of 2016. January 1st, 2017 is the official date. So you probably want to select some other technology, whether it's 2G CDMA or 3G HSPA today. And indeed, 4G LTE is also an option. But today, just yet, 4G LTE has some power constraints as well as radio cost constraints that might make it difficult to make that a choice for today. But within the next few years, you will see new standards that will reduce power, as well as the cost improvements. LTE is on a pretty steep cost curve decline, and therefore you'll be able to migrate to an LTE solution within the next 18 to 25 months, 24 months, give or take a few. And finally, for these kinds of applications, controlling cost is essential. So you have to have optimized use of your data. Custom rate plans are essential. Pulling across rate plans, pulling across devices is essential. And of course, setting the appropriate usage alerts and automating the device controls such that perhaps you can have the device stop transmitting if it exceeds a certain threshold, etc., is very important. And runaway devices do happen. Sometimes you'll have a scenario where the device transmits a little bit too much or is running away and is using up its allocated bytes way too quickly, and you want to get the alerts to be able to disable those devices appropriately. So in summary, what is cellular being used for in monitoring applications, and how is it being used for? It's a good capable transport, and why is it a good capable transport? Because we have optimized it for remote multi-carrier transmission and controls to provide analytics for those business intelligence functionality. And of course, you need reliability and managed data services because machines are not tolerant for system vagaries or network vagaries, and you have to allow for that. The reliability that you need for M2M devices for best performance is absolutely essential. The ability to manage that device behavior in the cellular network is something that customers have to think through and understand that that needs to be done so that you're not causing a problem for yourself with the cost that might be uncontrolled, etc. And in summary, I would say that making sure the usage alerts and automated device controls are set properly is something that all customers, not just monitoring and control customers, need to focus on. So there's my contact information. I'm going to hand the controls back here to Dana, or actually you should move it on to Barry directly. Let's move to Barry. And Barry, if you will go ahead and present your information.
Okay, I assume you can see my screen now. I'm Barry Seasai. I'm president and founder of Telog Instruments. And my company, Telog, is involved in remote monitoring of water, wastewater, steam, oil and gas, irrigation, and other conveyance systems. But everything we do is remote monitoring. And this is traditionally an area that has been monitored by SCADA systems. SCADA, as you may be aware, uses radio and requires power, and SCADA RTUs are not traditionally well suited to be located in underground locations such as underground water vaults and sewers. So what we've done is we've packaged the technology generally found in cellular phones with primary lithium batteries to develop very low power, low cost wireless communication devices that could be deployed essentially anywhere, connected up through an M2M cellular network to provide remote data to our municipal customers about their system. So what I've got here on this first screen is a typical water distribution system identifying many of the remote monitoring applications of interest. And this starts from underground source water, or the aquifer, and it's important for utilities and users of underground water to know how they're affecting that aquifer over the course of a year or many years. Rain gauges, reservoirs, lakes, streams, treatment plants, pump stations, the amount of water in a water tower, performance and flow through pressure reducing valves, as well as water quality, and pressures throughout the water distribution system as they reach the residential customer. So this is a typical diagram for water distribution, and there are analogous diagrams for steam and wastewater collection, gas distribution, so forth. This is a slide depicting some of our products, all of which in this case have internal lithium batteries intended to power each of these RTUs for anywhere from 1 year to 7 years, depending upon the application. They all include an internal cellular antenna, the data recorder, and the cell phone module. This particular product has multiple channels. This instrument is intended for underground water level monitoring, and this product is intended to install on standard fire hydrants for monitoring pressure throughout a water distribution system. A typical network diagram, fairly basic. We have an RTU in the field monitoring, in this case, a water flow meter, pushing data up through the cellular infrastructure to a server. Typically, our servers are located at a commercial data center where we're collecting and managing data for our customers, and then serving that data up to our customer from a website view. Telog or our customer can then manage the server for setting up the site applications such as call schedule, alarms, measurements to be made, sampling rate, so forth. So I have a few slides of applications, and this first one is for water flow and pressure, which is the title of this webinar. But a Telog RTU located in an underground water vault connected to a battery-powered mag meter. So what we're doing here is monitoring flow through the mag meter and pressure at the site, collecting the data in the RTU, and pushing it up to the server through a cellular antenna that's located at ground surface. The advantage of this system is everything is underground, everything is battery powered. It's not obtrusive, and it's not available for vandalism. relatively low cost, and the customer can install it in typically less than an hour. And before they can drive back to their office, they'll have data up on a website. This is an example of some of the data results that you could see, but the ability to zoom in and zoom out on data, view both pressure and flow on a single graph, and we provide some analytical computations for the view that you're looking at, including total flow, average max pressures, those kinds of things. So this is an HPR hydrant pressure recorder mounted on a standard fire hydrant. This is a 2.5-inch nozzle of a fire hydrant. This product, again, has a battery, data recorder, pressure sensor, cellular modem, and antenna all built into this one enclosure. This is the data that you would receive for pressure over a period of time. This is a few days. And you can notice there's a few transients that have occurred also in the data, in the pressure data. With our software, you can zoom in on it and actually look at the individual transients. In this case, this is a water hammer transient that reached 160 psi. It started out as a negative pressure event. Aquifer level monitoring is usually long-term monitoring where you only need to measure or sample maybe once a day or even hourly, record the data. But what you're looking for typically is what is my aquifer doing over long periods of time. So this Telog RTU is located in a wellhead above the borehole, and the sensor can be located at depths of 20 feet or 600 feet, whatever the application is. We just recently shipped 3 units to Kenya, East Africa, and they were installed in the morning, and before the customer was able to get back to their office, they had data up on their computer identifying what their levels were in their aquifer. So this is data that was pushed back over the Aeris network to our server here in upstate New York, and then presented on the customer's website. It's a lot of technology just to look at groundwater. It's another application of monitoring level. In this case, it's the tank level of above ground water tanks for water utilities. Two different ways to do that. One is with a submersible level sensor dropped into the tank. Another way to monitor that is measuring the pressure of the entrance or exit line of the water tower from below. But in both cases, it's a Telog RTU with a pressure sensor, monitoring and recording pressure, storing the data, and then transmitting this back over M2M Cellular back to our server. This is an example of a pressure reducing valve. Pretty much all water distribution systems use PRVs or pressure reducing valves throughout their system, particularly if you have gradients where you have to drop pressure before it reaches residential areas. PRVs are particularly problematic, so monitoring the input-output pressure of PRVs is an important task for water utilities. In our case, we can monitor input pressure, output pressure, and the valve position of a PRV, and knowing that data, we can compute flow through the valve. So customers getting not only pressures at these sites, but can also be considered a poor man's flow meter. And this is the data that you could view from a PRV monitor. Note that the red line here is flow, and there's multiple PRVs feeding this particular pressure zone. So the flow at night is dropping to 0 through this particular PRV. Having data from multiple PRVs allows the user to adjust their system so they can essentially calibrate how much water is supplied by each PRV or each supply zone to that pressure zone. And my last slide is a rain gauge monitor, a typical rain gauge, tipping bucket rain gauge, where the more it rains, the more tips we get, which are essentially contact closures from the rain gauge, recorded in a RTU in intervals of 5 minutes or 15 minutes, and then pushed up to the server over the M2M cellular network as frequently as the customer wants. We have an algorithm built into our rain gauge monitor so that it calls infrequently when it's not raining, but more frequently when it is raining. So you'll have real-time data effectively on your data presentation depending upon the rain conditions. And that's all I have. Back over to you.
Barry, thanks so much. Good stuff. We have one last presentation today, and just a reminder to all of you, if you have any questions, do put them down in the questions box in the lower right side, and we'll do a Q&A after this last presentation. So now I'd like to turn it over to Willie Chan, who is a marketing manager at Symmetry Electronics.
Willie, you may need to unmute.
Yep, good to go now.
Thanks.
Okay, so first I'd like to thank everyone on the call today, especially the Aeris team, for allowing us to participate in today's webinar. My name is Willie Chan. I'm the marketing manager here at Symmetry Electronics. And today I'd like to describe who we are at Symmetry and how we go to market. I'd also like to discuss how both Symmetry and Aeris work together to assist industrial monitoring customers. And lastly, I'd like to discuss and talk about our different product offerings, specifically our Aeris evaluation kits based off the Telog family of products. So Symmetry Electronics is a design-oriented, authorized distributor of wireless, video, and embedded products. We're founded in 1998, and we are a privately owned company headquartered in Southern California. We have a global presence with offices located in all the major markets in North and South America, as well as Asia. We also own and operate the semiconductorstore.com, which is our e-commerce website, where customers can buy our products as well as receive useful information on development tools and other resources to help support your design. So our go-to-market strategy is a little different from the other distributors in the market today, but our philosophy is pretty simple. We focus on innovative products and the markets that need them. So each of our products on our line card is a result of much time and consideration to ensure that it best meets the markets that we serve. So therefore, offering lots of engineering support is one of our key differentiators. In fact, most of our staff is highly technical and comprised of engineers. They go through extensive factory and in-house product training, enabling them to make sure they provide the utmost guidance and support in order to, in all the phases of the design cycle, but with the end goal to get your product to market as fast as possible. In addition, Symmetry offers centralized technical support from headquarters with the help of our technical marketing engineers. Now these guys act as the first line defense whenever customers experience any kind of technical issues. They have a lot of hands-on experience with evaluation kits and the technology, and they really do have a direct line of access to even our suppliers' engineering staff. Anytime customers encounter any issues, we're able to quickly respond and help troubleshoot with just by picking up the phone or sending a quick email. So bottom line, we're not just like one of those other distributors out there, but our staff can really help accelerate your design cycle by offering many different types of services such as architecture definition, circuit board design, schematic and layout reviews, antenna design and matching, even do custom solutions and offer inventory and logistics programs as well. So we do a lot more than just sell product. Let's take a quick look at our line card, and I broke this out pretty much by our wireless, video, and embedded product lines. But today I'm just focusing purely on our cellular suppliers. Telog Wireless Solution is our main cellular offering. It's in fact one of our top lines here at Symmetry. For those who have not heard of Telit, these guys are one of the market leaders today in M2M modules, as well as GNSS devices. You know, we have a long-lasting relationship with Telit. We work extremely well with their staff. They put forth a very high-quality product and even offer lots of technical support as well. However, we also offer other Telit-based suppliers on our line card: Janus, Multitech, and NimbleLink. All three of these suppliers offer their own pre-certified cellular solution that uses a Telit device. But best of all of our cellular suppliers offer Aeris-based hardware solutions that are available today. So whether you need a cellular module or a pre-certified modem, Symmetry could basically help define exactly what you're looking for, while Aeris is able to customize a plan and create a platform for the connectivity piece as well. Now that I've kind of mentioned the different technologies, I think it's important to highlight how these different technologies allow us to gain a clear focus on specific vertical markets. As you can see, there's a lot of different verticals that we reach today: medical, consumer, automotive. But the one that we see that's most prevalent right now is the use of cellular technology in the industrial automation market. This is one of the fastest growing verticals, not only for Symmetry, but for our M2M suppliers as well. So we're definitely familiar with this market. We are currently assisting many customers all the way from proof of concept to certification to production, and even to the connectivity piece, obviously with the help of the Aeris team. You know, the strategy of focusing on key verticals is something that I think both Symmetry and Aeris have found to be quite successful in really getting customers to market really quick. Moving along, I want to kind of just talk about our e-commerce website again, semiconductorstore.com. Now, this division of our business has been around for over 10 years now, and it's won multiple marketing awards based on the content that we provide on the site. It's not a Mauser or DigiKey type website where customers are just buying things, and there's nothing wrong with that. But our site is really geared towards the engineering community. It's a great starting place for engineers to, you know, looking for new solutions on different applications. And not only will you find data sheets and app notes and white papers, but you'll find videos and blogs and block diagrams, some of the applications that we're working on or working with our customers on. And it really is a site truly made for engineers. And one of our top sellers on the Semiconductor Store is are these in-a-box kits that we've created based off the Telit family of products. This is a kit that basically has all the necessary tools needed to start a cellular design, including the EVK2 motherboard, the Telit and Aeris module, corresponding antennas. We've even created a getting started guide and a CD to help get customers up and running quickly. As I stated, we have an Aeris-specific 1X RTT as well as the EVDO evaluation kit available for purchase now. And if you guys ever run into any questions or any issues, you can quickly pick up the phone, give us a call, and we'll be able to help you right away. This is an example of our CE910 Telit-based Aeris evaluation kit, as well as our EVDO DE910 Telit Aeris evaluation kit. Now I'd just like to quickly share a success story of how both Symmetry and Aeris helped the customer get to market in less than a year. You know, this customer makes data loggers that basically monitor all the different control systems inside buildings. They reached out to us looking for, you know, a solution for the application. We were able to drill down and point them in the right direction using a Telit CE910 module, and then we introduced them to the Aeris team. And given Aeris' expertise in this market, we thought it'd be a natural fit for the customer. Well, in less than 9 months, we got the customer successfully designed in and into production, as well as getting Aeris set up as their primary connectivity partner. We even did a joint Symmetry and Aeris account call to make sure things are progressing the way they should be. And as a result, we're also working on new designs and with the customer forecasting pretty significant volumes for next year. So again, just a real-life example of what Symmetry and Aeris brings to the table when dealing with these types of customers. Just to wrap things up, just want to re-emphasize why both Symmetry and Aeris make great partners for your industrial monitoring design. From a technical standpoint, both teams are well-equipped, knowledgeable in this M2M ecosystem. We have basically what it takes to get product to market, not only from a hardware but from a connectivity perspective. We have the experience, the wherewithal to truly service customers in this marketplace. But lastly, because of our technology, our focus, our expertise, we feel we're not just another part of the supply chain, but we actually feel that we're a partner in your cellular design. So I think that's something important to note, that we're both invested as well. So my contact information, or our company contact information, is on the slide right now. Please feel free to contact us if you have any questions or anything like that. Before I go, I just wanted to quickly point one thing out again. Like I said, our main objective is really to get your product to market as soon as possible. And obviously one of the first steps to doing so is getting an evaluation kit into your hands. Well, starting today, Symmetry will offer a 10% discount to all the participants on this call for any Aeris evaluation kit. There's a coupon code below so you can save instantly. The code is right there. You can enter it at checkout. The part numbers are also there. But more importantly, Aeris is also offering 90 days of free connectivity along with these Aeris kits. So again, just for us to both be invested as part of your design, I think this is a nice way to show that we're definitely willing to do whatever it takes to get you up and running quickly. So contact your local Aeris representative for more information. Please contact us as well, and let us help you. Definitely take advantage of our offer. And that's all I got.
Wonderful. Thanks so much, Willie. I really appreciate that. Actually, will you do me a favor? Will you leave that offer up on the screen in case anyone wants to take notes down on that one?
No problem.
Barry, I've got a few questions for you. The first one is, are you guys exclusively using cellular? And if not, what other technologies do you use and in what circumstances?
So Telog started out supporting landline telephone, and then we migrated to radio, satellite, and Ethernet before we began using cellular about a dozen years ago. And today, we still support all of those technologies, but 95% of what we ship out of our factory today is M2M cellular. And the key reason is the coverage is so good, the cost is low, and it's very reliable. Great.
And someone asked about network technology. Are you guys on CDMA or GSM? And if you're not using LTE, or I guess the question is, will you transition to it, and why or why not?
Yeah, that's a great question. So we support both 1X RTT, GPRS on GSM, but we've introduced HSPA within the last year and are phasing out GPRS. So today we're mostly 1X and HSPA, but LTE is on our roadmap, but it's probably 2 to 3 years out. And the key reason is that LTE is great for super high-speed communications if you want to download videos to your cell phone, but we don't really need the bandwidth or the speed of data. LTE modems today are expensive. The certification process is difficult, and it doesn't offer us any key advantages. But most importantly, we think the LTE chips that are out there today are really first generation, and they'll be improved over the next few years, hopefully getting rid of for diversity antennas for small bandwidth applications.
Well, that leads right into another question that we got. This person asked, should we plan to use LTE for a deployment that we're planning for 2016?
That's a good question. Let me endorse what Barry just said. I think that LTE is still a little premature today for machine-to-machine applications, particularly, as Barry mentioned, you don't need the throughput. The cost is high. The coverage isn't there yet. So even in 2016, you could probably be doing design and development and getting your product ready. And at that time, we will also start seeing new radio modules appearing on the market that support perhaps LTE only in certain applications, and within a few years after that, they will become more widespread. So waiting for LTE by the 2017-2018 timeframe makes a lot more sense, but getting prepared for it, understanding what the technology can do for you in the 2016 timeframe is certainly the right way to go. Now, if your application needs the high performance, or you're looking for 15-year longevity of the product or something like that, then LTE perhaps is in the cards today, regardless of the cost and regardless of the coverage issues. But until it makes sense, don't jump is the recommendation that we would say. And when it makes sense, then proceed.
Okay, that makes sense. And I have another for you, Barry. I'm going to digress off of LTE, if you don't mind.
Sure.
How do you manage flow measurements of crude from wellhead with high sand and wax? Now, there's an inside baseball kind of question.
Right. Could you repeat that again?
Yeah, they're asking, how do you manage flow measurement of crude from wellhead, from the wellhead with high sand and wax?
Great question. I'm not that familiar with that particular application. Generally, what Telog does is we work with whatever flow meter or sensor the customer chooses to use. We provide an interface to the sensor, either communications like I2C or RS-45, Modbus, analog, digital input, collect all that data, and then push it up to the server. So that specific sensor that was asked in the question, I'm just not familiar with it.
Okay. Let's go back to cellular for a minute, Barry. You talked about your transition to cellular. What, if any, issues did you have with it, and how did you solve those?
So we've had tons of problems with cellular over the years. We started out with a Motorola bag phone about 10 or 12 years ago, doing DTMF coded data over analog. And we've transitioned through every cellular technology that has come down the pike. And we've had substantial problems in coverage, reliability, cost of service. But, you know, all of those issues have been resolved. Today, I would say the cellular infrastructure has excellent coverage, very good cost. The reliability is better than any other communication technology out there, and we've got a great deal of experience that we can point to support that. So, you know, like any other new technology, it goes through its growing pains, and we've seen that with cellular. But today, M2M data over cellular infrastructure is just very reliable and cost-effective.
Well, as the cellular market for M2M matures, we tend to see questions like this next one quite a bit, which is we're now turning our head from, okay, we've got it working, to issues like data security. So, Zee, I know that you spent quite a bit of time dealing with this. The questions about, you know, how do you protect data? What areas are most vulnerable? You know, what should people be thinking about when they're thinking about data security?
Yeah, there are a number of different, let's say, aspects to data security that you need to think through. I have a separate webinar on this at some point I will refer you all to think about what issues might arise. But the basic concept is as follows. It is the amount of problems or the degree of problems that you may encounter if there is, in fact, a breach of that data. If that breach is recognized and it is not of consequence, then perhaps you don't need to worry about data security as much as you thought. On the other hand, if the data that you're monitoring has some critical business action, or you're monitoring a particularly mission-critical deployment of sensors in a water distribution environment, perhaps, then you might want to have very good assurances that the data content, the transmission of the content, the recipient of that data is all properly controlled. So you might want to encrypt That means perhaps a little bit additional cost in terms of development to make sure the encryption algorithms are secure. And then you may also want to make sure that the recipient who gets that data gets it in a secure manner. So one of the things that we have done is help customers analyze their security requirements. Once you analyze that, then you take the appropriate measures as best as you can. Now, ultimately security is only as good as you can plan for, and you may have to come back and retrofit. So one of the other things that we do recommend for people who are concerned about it is the ability to do remote, perhaps modifications of the firmware and the device out in the field if you're worrying about that. Now, in our transport, unlike handset cellular, we do not put the data out onto the internet willy-nilly to allow people to access that data. It'll generally be a secure connection. And if you're serious enough, if the customers are serious enough, we'll put private lines in place, or generally a VPN is sufficient for most applications. So from the radio to the network to us, ultimately delivered to the customer, is generally very secure. We also have, in the past, from day one, incorporated the ability to constrain access to the devices, whether it's from the network or even two of our customers who might be in competitive markets not being able to access each other's data. That, by the way, is something that traditional cellular handsets, smartphones and the like, don't necessarily protect you from. You can have two customers, two handset users on the same cellular network who might be able to access each other's devices. We don't allow that. We prevent and block and ensure that data that is intended for a particular recipient or for a particular device from the network side is managed and controlled in an as good a manner as it makes sense for that particular application.
Okay, great. I know that this topic is big, so there's a lot we can be covering on this. And so if all of you are signed up to receive the newsletter from Aeris, when we do that webinar, you will get notification. We have a couple minutes left for questions. If any of you want to put something into the question box, we'll try to get to that. In the meantime, Willie, I got a few questions about troubleshooting and lifespan of devices. And so for you, what's the average lifespan for your technology?
Oh, great question. For the purposes of today, we're talking specifically about Telit. As you know, this is a module-based component, right? So there's a lot of other surrounding components onto the module, and if something goes end of life, it kind of affects the whole module as a whole. However, Telit has a really great relationship with their partners and their suppliers. Definitely well informed if anything like this will happen down the line. They're well prepared if something were to happen, going end of life. But for this product specifically, this 910, it was just released less than 2 years ago. Typically, their product families go 5 years plus, with no issues. So that's kind of the general average lifespan for these type of devices.
Okay, good. That's really helpful, Willie, because obviously people are putting these out in the field for long periods of time.
Correct.
The truck roll is expensive, and this is a key issue. And I know Z talked a little bit about battery life and ways that can be preserved as well. So thank you very much for that. This one for Z and Barry. There's a growing opportunity for M2M solutions where cellular is either not available or not ideal, but other means of connectivity are available. So they're asking, have you been successful in monetizing those types of applications? Do you want to go first, Steve?
Yeah, let me do that. A couple of points that are, I think, important in that question. First is that while cellular is a natural and good transport for many long-range machine applications, as you rightfully point out, coverage isn't 100% available where the geography is. We have customers who will occasionally have their devices be deployed or transported either in a vehicle or some kind of heavy machinery into regions where cellular coverage may not exist. Clearly, hybrid applications have a particular place. In the case of high-value applications, it might be appropriate to do a cellular satellite hybrid for certain remote locations, etc. And then there is a class of new consumer IoT applications where even the cost of cellular radios might be prohibitive, or the size of the radio transmission, the power requirements might be inappropriate for that IoT application. So you might see solutions that are using some of the more low-power wide area network technologies that are being deployed or starting to be looked at today. These technologies are still fledgling. The coverage doesn't exist. On the other hand, there are plenty of players that are starting to get into that market, including future LTE deployments where certain low-power scenarios could be made available to customers for IoT and M2M applications. Clearly, we're looking at those, and when it makes sense, when the coverage and the requirements from the customers to use those technologies becomes more firm, we will be providing those capabilities. In our solutions, while we provide almost 100% cellular connectivity today, there are hybrid applications being deployed by our customers, number one, and number two, we do provide data content and analytics capabilities that are completely transport agnostic. And so if the data comes in from a wireline connection or an ISP connection or even Ethernet connected from a building or whatever, it is perfectly capable of being incorporated into our system for analysis in conjunction with the cellular transport. So their future is bright, and I think for many applications we'll see a combination of low-power technologies as well as satellite technologies. Barry, I think that if you have any comments about this as well, I'd love to hear from you.
Yeah, so I think the hybrid approach that you mentioned is something that we see all the time because our customers are typically municipal utilities, and although everything we do is monitoring outside the fence, the customer will often want to bring data into the same server, the same platform, so they have a common reporting engine for data that is obtained through means other than cellular. For example, they may have data in an Ethernet environment within a plant, a process plant, and they want that same data to be merged with all of their remote data on a common platform for reporting purposes. So we see a number of applications where we're doing hybrid work for both you bringing in data from Ethernet as well as satellite where there is no cellular coverage. Although those locations are disappearing, but for example, up in monitoring unattended hydro dams up in the Adirondack Mountain, there are a few spots today where there is no cellular coverage as yet, and those are applications where we would support IP data over satellite.
All right, yeah, that makes sense. Even you have to be flexible to the needs of the client. Willie, anything to add on this particular question?
No, just we see a lot of different applications as Barry just mentioned, satellite being one of them, and just to throw a quick plug in, we also do have other satellite solutions that we do offer as a complementary piece to the Telit and the other cellular solutions as well. So most of the case, those are type of the pairings that we'll see, especially in hard to reach markets. But yeah, that's pretty much it from our side.
Okay. Well, we have time. Let's do one more question. And this one we've heard come up a lot. You've been on the road talking about this a lot. And you mentioned it very briefly in your presentation about the 2G sunset. And so this person asked, what are their options at this point? I mean, obviously time is running short. So if they have a 2G solution with AT&T, what can they do?
That's a darn good question. I think AT&T has essentially sent out a timetable that is very clear. They have said that by January 1st, 2017, customers should not expect GSM, GPRS, and edge services, 2G GSM services, to exist anymore after that point. And some years ago, they made the decision to essentially stop deploying any more devices out in the field to prevent any further issues that might arise after that sunset occurs. Completely reasonable. I understand their purposes, and as you'll see from my webinar that I have talked about on this topic, and done presentations as well, I understand their requirements and why they needed to do it. So if you have an existing 2G GSM GPRS unit out there, you probably need to be thinking about swapping it out, changing it out for a different kind of device. If it's you could have a 2G CDMA solution that will extend that runway further, or you could have a 3G HSPA solution which will extend that runway further, because you need to do it. You need to replace the device. And obviously, if the 4G LTE solution is available and works for you, that is also a viable option. On the other hand, for many applications that were relying on the low cost of GSM GPRS radios, migrating to a 4G LTE solution today is not necessarily a financially sound decision. On the other hand, within 2 to 4 years, it might well be. So I would expect that by the time GPRS goes away at the end of 2017, most customers will be well underway in deploying a 3G or even planning for and starting to deploy a 4G solution in volume within a year or two after that. So that the transition away from 2G GSM needs to occur. Now, one of the comments I have made in my presentations is that you need to think about the fact that cellular technologies do evolve, do change, and you need to allow for that potentially in your design and in the applications. If there's an opportunity to be able to go out and touch the device and it's not cost prohibitive to do that, then planning for perhaps a replaceable radio cellular module or planning for devices that can be updated physically by having someone touch it when the battery is replaced perhaps. Those are all the kinds of things you need to plan for the future and in general be aware that technology does migrate and move on and be ready for it.
Great. And for the person who asked this question, I might also recommend you give a call to an Aeris representative because we did make public an offer about a year ago. Anyone transitioning away from AT&T to GSM, we are offering a SIM swap. So all the cost of all the SIMs would be absorbed by Aeris. So a nice opportunity to reduce the pain that comes with making that transition. So we are out of time. I want to thank you, Barry Sisai and Willie Chan and Z Hossein for being with us today. If you have other questions, feel free to reach out to us, and we hope you'll also take advantage of this offer with Symmetry and Aeris. Have a great day, and thanks again for attending.
Thank you.
Thank you.